writing so much SQL. And finally, test your code. Seriously, test your code. Now, obviously, again, this doesn't cover the full gamut of what we can address in the world of PL SQL, but this is some pretty good stuff. So let's take a closer look at each one of these. First of all, take care of the host body. Maybe I'm starting to talk about this stuff because I'm getting older, and as I get older, my body is less tolerant of what it means to be a programmer full time. We make a living from the product of our brains, and we're really lucky. Just think about it. They pay us to sit around, think about things, essentially do logic puzzles, Sudoku. They pay us, and we write it down, and wow, everybody thinks we're amazing. But let's face it, it's all done by our brains. So if our brains are not in good shape, we can't make a good living at programmers, and we can't write good code. And our brains need our bodies for nutrients and for inputs. So take care of your body. And what that means on several different levels is, first of all, drink lots of water. I think a lot of us drink way too much Coke, Diet Coke, caffeine, coffee, and that dehydrates our bodies, and we don't drink enough water. Dehydrated brains don't work very well. And you'll find if you drink a lot of water that you're more alert, more energetic, and you can think more clearly. Take lots of breaks, move around, stretch. We did not evolve into the bodies that we are because we were made to do programming. We're not made to sit around for hours every day. And I encourage you to take care of your body if your wrists are bothering you, your knees, your back. Get some exercise. Particularly, you need a strong abdomen to avoid back pain so that you can sit there for hours and really focus. I know you probably didn't come to the session to hear me talk about doing lots of sit-ups, but do lots of sit-ups. It'll help you be a better programmer. All right, fine. Let's move along and talk about some software stuff. So first of all, strive for a single point of definition. Now, this is a fancy way of kind of introducing yet another acronym that I kind of like. It's SPOD, single point of definition. It's really another way of saying the same thing as avoid hard coding of values. Don't repeat anything in your code. That's the general mantra. Specifically, don't expose the implementations of low-level infrastructure elements like error management, logging, SQL statements. Hide your business rules and formulas. These are some examples or variations on the theme of single point of definition. The main idea from a theoretical standpoint is that if you define something in one place and all your usages of that same logical thing, whether it be a value or a formula, anchor back to that original definition, then if that original definition needs to change, you change it in one place, and the ripple effect automatically carries through the rest of your application code. The alternative is that you define the same thing in multiple places or variations of the same thing, and you might fix it in one place, but how do you know you fixed it in all the different places? Now, doing SPODs, avoiding hard codings and avoiding repetition, might not be a big deal. It might be a waste of your time to even worry about this if the applications we wrote were static. But they're not. They're always changing. And they're always changing because the software we write is really an attempt to reflect part of the complexities of the real world, which is always in itself changing. Since that's basically what we're doing, we have to accept that change is going to occur and build it into the way we write our code. And one very important way to build it in is to recognize the change and avoid the repetition. Now, there are lots of manifestations of multiple points of definition, MPODs, but here are some examples. Some of them will be very obvious, others less obvious. Literal values. If you read in your documentation that you're building a report subsystem, and it says that you will never deal with more than 150 reports at a time, you don't want to put 150 hard-coded in your application code. I bet a lot of you know that and more or less avoid it. Here's another one. Every var-car2 end declaration is an example of hard coding and should be avoided. And inserts into that log table when you're doing database error logging, and you write the insert into your log table explicitly in your application code, also a great example of hard coding. Another way of putting it is exposed implementation. Also very bad news. Now let's take a closer look through some examples of these things. Let's Spotify some code. So here you go. You come to a seminar on best practices and you get a new terminology, Spotification. Let's Spotify some code. So take a look at the box in the top left. Create a replace procedure, process employee. Takes an employee ID, and then I start implementing my code. Now I read the documentation for process the employee, and it says the first thing you have to do is get the full name of the employee. And the documentation is very clear about this. The full name of an employee is last, comma, first. After you get the full name, you then go on and do a whole lot of other stuff. And this is the code that I wrote. Let's do some code review. Now, we're not really set up for you to give me your feedback about this code. I'm going to have to do it all by myself. My apologies. And in fact, if you have questions, it's best not to use the chat section. But hopefully, if I talk fast enough, we'll have time for some Q&A at the end. So let's just take a look at this code and how I went about writing it. Well, the employee ID is a number, so I pass it in as a number. Then I need to declare a variable to hold my last name. Now, I've got a problem. I know that this last name should be anchored to some column in the database. But when I go to look at the columns in the database, and let's do that right now, I'm going to switch over to Toad. There we go. And I'm going to bring up my schema browser for HR. If I go and take a look at the HR table, employees, I find that my first name column is 20. My second column, last name, is 25. I don't have a full name column to anchor to, but that's okay. I add up 20, 25, I add 1 for my comma, and I give myself some margin of error. And so I end up writing code that looks like this. varchar2 100. And I say to myself, that's fine. It's never going to get that big. And I keep going. And I keep going by writing last comma first in my application code into my local variable for my employee ID equals my employee ID coming in through the procedure parameter list. So what's wrong with this code? Wow, just about everything, just about every line of code you see has a problem in this procedure. First of all, when I'm sending my employee ID in, I really should use a percent type against the employee ID. That way it anchors back to my column definition. But here's a really big problem. I've declared the name of my parameter as being the same as my column. And notice my where clause. I bet a lot of you saw that right away and you're shaking your heads. That's insane. That's like saying we're 1 equals 1. And a common best practice, of course, is to make sure that you use prefixes or suffixes that differentiate between your parameters and your columns. That's cool. Okay, let's take a look at that varchar2 though. This is what I described as being one of those hard codings. Now, you heard me say, this should be more than big enough. I took 20 plus 25 and I doubled it, 100. It's never going to get to be that big. And hopefully a lot of you are saying to yourselves, no way. It could get that big. It could get bigger. And then I'll get a negative 6502 error, a value error exception. So here's the general rule of thumb. When you're writing your own code and you're listening to yourself think, or you're doing some code review with a friend of yours and they're telling you about why they wrote the code a certain way, if you ever hear the words never or always, and they don't occur in the following 2 sentences, it's never going to stay the same, or it's always going to change. Right? If never or always appears outside of those 2 sentences, then they are putting a bug in their code right there. To say that the string will never be bigger than 100 is just silly. But we tell that to ourselves because we're looking for some kind of stability, psychologically, in the world in which we're writing our code, and also we're kind of lazy. What else are we going to do besides put some kind of number there? Now, I could do varchar2 32767. That's the biggest size possible today. But even that's a problem because I've hard-coded my limit. And in Oracle 12G or 13, I don't think it's going to happen in 11G. In Oracle 12, they might expand the maximum size of a varchar2. So you really don't ever want to see varchar2 ends in your application code. Let's move on, though. We're not done yet. I think, in fact, the worst problem in this code is the exposure of the business rule. I read in my document that it says last comma first. And in fact, they've been saying that. The users have been saying that for months now. We like to see stuff last comma first. And so in 1, 10, 25 different places in my application, last comma first appears. And it seems perfectly reasonable. We show it to the users. We go through QA. They love it. It goes to production. And the day after production, the user's manager calls and says, you know, I'm really sorry, but we changed our minds. We want it to be first space last. And your manager has to groan and take it. What else can she or he do but say, no problem, we'll fix it for you? But that can be a serious challenge to fix. What do? Search for last name, for comma, inside quotes? Very challenging. So what you really want to do is hide your implementation of business rules, hide your definitions, aim for single points of definitions. So take a look at the bottom left-hand box now. This is the way I think your code should look. Now, let me first preface it by talking about the different kinds of developers that might be in a single organization, or the different hats you might put on as a single person writing code. When I'm writing code that responds to business requirements, I'm truly an application level developer. Joe says that he needs a program that will get the full name of an employee and display it. That's a business requirement. and I'm going to write the business requirement. But there's a whole lot of low-level stuff that goes on in an application. For example, record the fact that an error occurred, log some tracing information, get information from the database, write information to the database. These are all a sort of low-level service that the high-level application developer generally shouldn't have to deal with. And that's what you see here in this bottom left-hand piece of code. I need to declare a variable called name or a full name. Now, what type should it be? Well, the standards in my environment is that for all my different tables or business entities, like the employee, I have an RP package, the rules package. And it has within it all the rules, formulas, everything that has to do with that employee. And what you see here in my rules package is that I've also declared not only a function to retrieve the full name, which I'll come back to, but a subtype statement. The subtype is a very special and useful statement in PL SQL. It doesn't actually do very much at all. You're just providing an alias for some other type. What I'm saying is that the full name T type is another way of saying varchar2 200. But the difference here is that I'm putting a logical name on top of that varchar2 200. You can think of this as the physical implementation and this name as the logical implementation. And in my application code, I always refer to the logical level. So if I ever need to change, if like the varchar2 200 is too small and I need to make it 1,000, I change it in just one place. I recompile my package spec. I recompile all the packages that it depends on because that's how it works in Oracle. Those are invalidated. But I don't have to actually change my application level code. It stays the same. It just takes on a new meaning with the latest compilation. Sweet. So I, as a developer, don't have to know about the maximum size and what the rule is for those things. I just reference a pre-existing service. Same thing with my query. Rather than writing select last comma first into a local variable and forgetting, for example, probably to write a no data found and too many rows exception handlers, I simply call a function called full name, and it gets me the information. I pass it the employee ID, and it gets the information back that is needed. Now think about it. As an application developer, I know that I need to get the full name, but I no longer have to know what the rule is, what the formula is. I no longer have to worry about handling no data found or too many rows. The function does all of that for me. So it's a services-oriented architecture for PL SQL developers, and we can build it ourselves. So here's an example of some basic spatification. Start out with a hard-coded data type, an exposed implementation of my formula, the actual select statement itself, and all of that largely goes away and is replaced by high-level references to predefined elements. Good stuff. But there's more. Here's another example of spatification. Error handling. Now, it's extremely important when you're writing high-quality code to make sure that you anticipate the kinds of errors that might occur and trap them and resolve them, or put in handlers for unexpected exceptions to record them so that the debuggers, the support team, can try to sort out what went wrong. And all too often, this is the kind of code that gets written. Let's see, I'm doing some work with a company ID. And if I don't get a company, if there's no company found for this ID, the documentation says, record the fact that this occurred. We had a missing company, but it's not that big a deal. Keep on going. If anything else goes wrong, record the fact that the error occurred and stop the program from continuing. And this is what I end up with. I happen to know that we log errors into this error log table. So I write all this insert statement, hard code all this information like the name of my program since I don't know where to get it. And I don't raise an exception because I am allowed to continue. When others occurs, I do my same, more or less, my same insert, and then re-raise the exception. Now, this code has an enormous number of different problems in it. But the biggest problem is the desire, the deep need by the programmer who wrote this code to believe that this will never need to change. Imagine seeing exception sections like this in hundreds of places in your code, an explicit insert statement into your log table. What if you upgrade to Oracle 10G, or when you do upgrade to Oracle 10G, and you discover this amazing new utility called DBMS utility format error backtrace? This utility will actually tell us the line number on which the error was originally raised. Really incredible, fantastic information. Now, if I wrote code like this, and then I found out about error backtrace, I would have to go to every single insert in my application and add a new column to my table invalidating all my code and adding a call for that function. That's total insanity. It's hard-coded, it's exposed, it's clunky, and it's redundant. Let's take a look at the spatified version. What I've done now is replace my hard-coded exposed implementations with calls to a predefined generic error handling package. And rather than write code saying, record the error by sending it into a table or a file, and then raise an exception by, to stop it, I simply choose the appropriate error handler by name. I want to record and then continue. And I pass in just the information I need. And in this case, I want to record and then stop. And I just describe the activity. I don't have to decide how to record it. I don't have to type all the names of the columns. And I don't decide how to stop the program. It's done by my low-level infrastructure standard. Now, this is the kind of standard approach that developers might actually use. Of course, if you're like me, you hate standards. You hate somebody telling you there's a better way to do it, and in fact, it's a standard lowest common denominator way to do it, which is how we interpret it. I think the way you want to adopt standards in your organization is to use the carrot approach. Hey, Stephen, check out this package. It used to take me half an hour to write an exception section. Now I can do it in 2 minutes. This is great stuff. And before you know it, everybody in your organization is following standards. They love it, and they don't even realize it. And don't tell them, because once they know it's the standard, they'll probably stop doing it. But the bottom line, again, is that you're hiding all of this repetition, you're hiding all the hard-coded logic, and replacing them with high-level calls. Now, later on in this talk, and at the very end of the slide, I'm going to show you some links to resources. And I'll tell you how to get some code that already does this for you, because writing these kinds of reusable components is certainly challenging, and you generally don't have the time to do it. Okay, so that's my spatification. That's my discussion of avoiding repetition. Let's move on to my next topic, tiny size your executable sections. Now, if you're anything like me, over the years, you've done more than your share of write enormous blobs of spaghetti code. Procedures, packages, functions that have hundreds of lines, thousands of lines in the executable section. And I'm sure you know that if you try to look at this code, you wrote it. If you try to look at this code 3 months later, it's virtually impossible to understand and maintain and debug. And you end up with a lot of code redundancy as well, because the code is just spread out over so much territory, you can't even keep track of what you did. That is a pathway to total misery. Maybe not misery for you, maybe for the next generation of programmers. And the way I think you should think about this, especially if you're young or relatively middle-aged and have young children, is that one of you probably has a child who will grow up to be a programmer, maybe many of you. But one of you might have a child who actually maintains your code. Think about that. Now that's scary, right? Now, you basically are faced with 2 options at this point if you're concerned about your child having to maintain your code. Number 1, never put your name in your code, so they'll never know it's your code, which is kind of sneaky, but you could do it. Number 2, write your code so that it can be easily maintained and understood, so that you're proud of your code, so that if your child ends up maintaining it, she or he will say, wow, my mom wrote this. That's really cool. Okay, so enough of that. What should you do? How can you achieve this ideal of writing readable, maintainable code? First of all, you need to write lots of small, narrowly focused, easy to reuse packages. Don't write a procedure that has hundreds of lines of code in it, or one package with 5 programs that has all the logic in your application. You should have a separate package for error management, a separate package for string utilities, for date utilities, for application-specific formulas. The more of these you have with very, very clearly defined names that focus on just 1 or 2 specific tasks, the easier it is to reuse that code and to identify the code and find it. But second of all, and what I want to focus on now, is that inside a given program, you might have a lot of complexity to deal with. And it's hard to deal with all that complexity. So what you want to do is use top-down design or stepwise refinement combined with all of your packages to achieve a very high level of modularity and small executable sections. And another key aspect of this, though I don't think I'll show you an example today, is to hide your complex expressions behind constants and variables. In other words, instead of writing a statement that says if A or B or C and B or C or D, in this big complex multi-line statement, assign some of those sub-elements to variables, and then you can write simpler structures. But what I want to focus on mostly today is the tiny sizing of your executable sections. Because in the process of writing code the way I'm about to show you, you can actually get rid of most of your bugs before you write them. And that is really nice. Now again, as I mentioned, we can deal with a lot of complexity. We're trained to do that. Others actually can't, at least in the abstract sense of juggling stuff in your head. But still, it's easy to run out of gas. If you're told to write an order entry system, you know it's going to be an enormous task. You don't just start writing the programs from line 1 through line 25,000. What you do is break up that complicated task into multiple subtasks that are more manageable. I'd like to give you an example of this. Suppose that I'm on a team that's writing a call support system. So people call in with problems, and we either answer directly or we put them in a queue to get back to them. My manager comes in Monday morning and drops 50 pages of documentation on the table and says, Stephen, it's your job to write the assigned workload procedure. And it's pretty scary looking at 50 pages of documentation and thinking, wow, hopefully the users got it right. Fortunately, the first page is an executive summary. And I'll read the executive summary to you. It's right here on the page. For every employee in the department that was passed in, if the caseload for that employee is less than the average caseload for that department, in other words, if this person is relatively speaking underutilized, assign the next open case to that employee and schedule the next appointment for that case. I could literally read to you the executive summary because I translated it from English or whatever the original language was into valid PL/SQL code. And I did that by using modules, named program units, but several different kinds. Let's take a closer look. Now, when I read the documentation, the summary, and it asked for things like the caseload of an employee or the average caseload of a department, I happen to know about this analysis package. It already exists. Maybe I wrote it. Maybe it's a common part of the toolbox. So I was able to invoke these reusable modules directly in my executable section. Great. However, a lot of other stuff in this program logic is way too specific. For example, I have to assign the next open case. And I've looked ahead in my documentation, and that's like 25 pages long. It's really complicated. I don't want to deal with that right now. What I'm going to do is give it a name, assign next open case, and focus instead on what has to go in and what comes out. And I'll codify that idea about this program that needs to be written by creating it as a subprogram unit inside my main procedure. So just as you can declare variables, cursors, types in your declaration section, you can also declare procedures and functions. These are called local or nested modules. They can't be called outside of this procedure. They're only available here, and they only exist for the duration of the execution of that program. But what I can do is create a very simple stub, empty program for that, for schedule a case, for next appointment. And then, even though there's nothing in these programs, I can compile my code. And what I get by compilation is a validation that the way I've structured my executive summary is correct. My inputs match my outputs. It all holds together. And then I say, okay, now I'm ready to deal with assign next open case. And I open up this procedure, and I go to its executive summary, and I've got another 5, 10, 20 lines of code that neatly captures the overall logic at that level of detail. And then inside procedure next open case, I might create another nested procedure, and within that one, another nested function. It can go 4, 5, 10 levels deep if you so chose. I've usually gone about 4 or 5 levels deep, and that's kind of enough. But by taking this approach of keeping your executable sections really small and deferring the details, the complexity, to a lower level, in other words, only until you actually need to address that level of complexity, the result is that at any level down, the code is transparently easy to understand. And also, as I said, as you write this code, you're going to get rid of the bugs before you can possibly write them, because how do you fit a bug into logic that looks like this? You're simply describing the requirements, and it just can't happen. The chance of a bug just goes way down. Your code is much easier to read and understand. Now, there's no question that having a tool like Toad makes a big difference when you're working with tools like this. Toad has something called the Program Navigator. Let's hop over to it. I know, hop over to Toad. I keep saying that, but I don't mean to make it as a joke. And let's pull up one package that I find to be a good example of showcasing the Program Navigator. I'll go out to my demonstration directory. In fact, I'll tell you where you can get all of these files that I'm running today at the end of the class. This is a pretty big package, several thousand lines long. Here's the Program Navigator on the left-hand side. And it lets me look at all the individual programs in my package, but also I can drill down into my packages. Notice there's a nested program. It has a nested program and another nested program after that. So here's an example of 5 levels of nesting. Without something like Program Navigator, it would be very hard for me to move between my different programs. But with the Navigator, it's a dream. It's really easy to do. Okay. So keep your executable sections really small, no more than 50 lines, because at 50 lines, you're basically fitting out the full size of a page or a screen, and you really want to be able to capture the logical sense of your program at a glance. Moving on, stop writing so much SQL. Here's my feeling. PL SQL makes it way too easy to write SQL. We take it totally for granted, and it is quite elegant and beautiful. If I need to write a select, I just write the select statement. I don't have to do any nonsense like JDBC, ODBC, any kind of layers. The problem, though, again, is that it's taken for granted, and as a result, there are usually no controls or guidelines regarding how and where SQL statements should be written. Now, that's really strange when you think about it, because if you're taking a rational approach to writing high-quality code, then it seems like you would step back and say, what are the parts of my application that are most likely to change, the most volatile? And then what I want to do is isolate those parts that are most likely to change so that the impact of the change is minimized or at least controlled. Taking that logic, look at SQL. SQL deals with the underlying data structures, both the content of the data and the structures, the columns, the foreign keys, the relationships. That's the basic representation of your business. And that is always changing. Plus, it's also the most compute-intensive part of your application. If you're looking at performance bottlenecks, it's usually happening in the SQL layer. So one would think that if we were following a rational approach, we would isolate all of the SQL statements in our application, make them really easy to maintain, to optimize, to find and fix, and certainly avoid repetition. Here's the thing. You need to think of SQL itself, getting data, putting data back in the database, as a kind of service. When you're writing application-level code responding to business requirements, you should not write SQL statements. And Java developers, .NET VB, they should never write SQL in their front-end application. Instead, you should, when you need to get data, call a function that gives you your data. When you need to change information in the database, you should call a procedure to make the change as necessary. This is called data encapsulation, and as a concept, it's been around for a long, long time, but it's never really caught a lot of attention or momentum inside the PL SQL community or even beyond. A lot of people do it, and they're uniformly very pleased with the results. So I wanted to talk a little bit about data encapsulation, really not go into much detail in terms of examples. It is a big topic in terms of best practices. But what I will do is show you how you can achieve comprehensive data encapsulation for absolutely free. So the basic idea is that you generate, don't write because it just takes too long, a standard API to interact with your underlying tables. Basically, the idea is that for every kind of insert or update or delete, you would write a procedure. For every kind of retrieval, not write, you would generate. For every kind of retrieval, get me one row. Get me all the rows in a table. Get me all the rows for a particular foreign key. You would then call a function to get that done. In fact, I'll show you an example of that in just a moment after I go through this page. Now, there's no way that you can possibly generate all the kind of SQL that you need, so then you collect all the custom logic for a given table or a business entity into an extra package. But you always make sure that there's only one implementation of a particular single statement, SQL statement, in your application. No repetition. And again, never, never let Java developers and .NET developers write SQL. It's bad news. They don't like the language. They think it's a dumb language. They don't know how to write it well. You should do it in PL SQL. So let me first of all break off and show you how I think you can do this. What I'm going to do now is connect to the schema that holds the back end of my unit testing utility, which I will show you in just a little bit later today. Let's connect to the back end. It's an Oracle back end with about 30 tables. And to speed the development of my unit testing tool, what I did was generate most of the PL SQL code that I use. So here are my list of tables. For example, QU assertion. If I look at my list of procs and draw down my packages, I have lots of packages. In fact, 3 or 4 usually per table. If I go to assertion, we can see that I have a query package, the QP package. And it has all the functions, or most of them, that I need to get one row, to get all rows, to get all the rows for a foreign key, to find out if a row exists, etc., etc., etc. This is all generated code according to a standard API. If I need to change my data, I have a change package. And it does inserts, updates, get the next primary key, change all the rows for a foreign key, delete all the rows for a foreign key. And again, I don't have to write any of this code. And better yet, I don't have to write the error handling logic that goes along with it. And for example, in most of my insert statements, I have something like 200 lines of error handling logic. It's amazing what you can do when you generate code. So that's how I've been using it, and it greatly accelerated my coding development. Now, I used to feel bad about talking to you about data encapsulation because the best way to do it was to buy a tool that I had written to help you get the job done. It was called QNexo, which stands for Quality In, Excellence Out. Quest acquired this technology from me a few months ago, and we've decided to release it as freeware. So starting this October, and there's going to be a big announcement as to where you can get this, but I can't quite tell you yet. We're going to rename it the Quest Code Gen Utility, and it will be available as freeware off of our website. In the meantime, however, you can go to qnxo.com and download and use the trial version of this product. It's actually not the trial version, it's the full production release. And you can literally start up this product. I'm not going to do it now, but start it up, point to a table and say, generate all these packages for me, and it does it for you. You don't have to do anything else. You can just start writing it, taking advantage of it. Now, whether you do it yourself, whether you generate these APIs or write the code yourself, it's just extremely important to stop writing so much SQL. Whoops, I went backwards. My apologies. So just to catch up there a little bit, I strongly encourage you to download this utility and try it out. Stop writing your SQL, generate most of it at least for yourself. However, if you have to encapsulate by hand, at least keep in mind the following things. When returning multiple rows of data, for example, a Java program needs to get all the employees for a given department. They shouldn't write the code. You should write it for them. Think about passing back the information to a Java program or a non-PL/SQL program via a cursor variable. If you're working PL/SQL to PL/SQL, pass the data back via a collection. When you're working with complex transformations of data, think about using table functions. And these are really interesting. Whoops, I'm sorry, my line drawing is going downhill quick. Table functions are functions you can call in the from clause of a query as if it were a relational table. Very cool stuff. And I think I can show you some of this just a little bit, but I'm going to run out of time, so at least I wanted to raise the point or point you in the direction of the feature set you should use. When you're doing single row queries, put them inside a function. And don't propagate the no data found exception. Basically trap it and usually return null, indicating that no row was found. And finally, whenever you're working with multiple rows of data, either pushing them to the database or getting them back out, use bulk collect and for all. These were introduced in Oracle 8i. They require the use of collections, which I'd mentioned before, and those are the PL/SQL array structures. And these can improve the performance of your multi-row SQL on an order of magnitude or more. It's really quite remarkable what these things can do for you. So there's a lot built into PL/SQL right now, both to help you improve the performance of your SQL and also hide the complexity of it and deliver it back to both PL/SQL programs and non-PL/SQL environments in a very coherent, simple fashion. But again, best of all, don't write it, generate it. Okay, moving along. I'm going to focus on my last topic, testing. Then we'll have some time for questions. And one of your questions could be, Stephen, tell me more about table functions. And then I'll go back there and do it. So, code testing. My best practice was test your code. Seriously, I mean it, test your code. And the reason I say that is, look, we all know that we don't like to test our code, and we don't do it well enough. Why is that? Lots of reasons. First of all, mainly because writing software is an awful lot of fun. Testing, it's really hard work, so we kind of like to do the coding instead of the testing. But there are some very serious ramifications of bugs. First of all, it's been estimated, this is actually back in 2002, by the National Institute of Standards and Technology, that bugs, software bugs, cost the U.S. economy at least $60 billion every year. That's a lot of money being spent on fixing problems that we should have largely caught to begin with. We all know you can't possibly get rid of all the bugs in your code, but I'm sure you all know that you can get rid of a lot more than we do get rid of. And this is kind of embarrassing, really. We're supposed to be professionals. In fact, sometimes we call ourselves software engineers. Would you want to drive in a car that had as many bugs as our software? Would you want to cross a bridge that has as many bugs as the software that we deliver to our users? I would argue no. I would argue that you would stay home and you would walk whenever possible. So we should really take ourselves more seriously and give ourselves more credit and work harder at getting rid of bugs. Fine, you say. Fine, I'll get rid of bugs. But how can I test my code? It's hard. Managers don't give us the time. We haven't had good tools to use. And to a large extent, we don't even know where to begin. If I was your manager and I said to you, Stephen, Joe, Sally, I want you to test your code very thoroughly, would you even know how to go about writing a test script, where to put the results, how to record the results, how to see whether or not your test worked? It's really challenging stuff. Well, I'm here to help. What I'd like to do is, first of all, offer to you my 6 simple steps for unit testing happiness, and then show you how to implement those 6 simple steps with my latest obsession, a unit testing tool called the Quest Code Tester for Oracle. So, 6 simple steps to unit testing happiness. First of all, let me point out that out of these 6 steps, number 5, almost all the way at the bottom of the list, is write your code. Writing good code, writing best practice-driven code, is often a matter of deferred gratification. If you're anything like me, you're a hacker. You would like to hack into code and write stuff and solve puzzles. That's great, but that doesn't necessarily produce good code. Really what you have to do is hold off a little bit and think things through. So here are the steps. Before you start writing anything, you need to make sure that you know what the required functionality is. Your users might have written up some documentation for you, but you need to really peruse those areas of functionality. Ask questions. Get the issues you have fully resolved before you start writing your code. Next, don't write your code. Think about the test cases. How will you know when your program is working? You think about it before you write your code, which I know sounds kind of odd, and I'll come back to it. Next, after you've thought about, well, these are the criteria by which I can determine that my program works, define just the header of the program, the name, the parameter list, the return value, not the implementation. Defer the implementation, compile it into your database as a stub program, and then build your test code. In other words, before you write your program, build your test code, which I know will sound upside down to you. Next, finally, write your program unit. And then we enter the standard cycle that I'm sure all of you are used to. We test our code and we discover that there are bugs. We use the source code debugger, of which Toad has a fine one, to isolate the lines of code that caused the bug. Fix those lines of code, do it again, do it again, do it again, do it again, until somebody tells you that your code is working. Those are the 6 basic steps. And then, every time you get a bug report, you should go back to step 2 and work it through your system again. Because if you got a bug, you actually found 2 bugs. One bug was in your code, the other bug was in your test cases. You didn't check for that bug. So fix your test cases to reproduce your bug, and then go ahead and fix it. Same thing with enhancement request. Add it to your test cases, and then implement it, and then test it. So 6 simple steps. Defer writing your code. Build your test code before you write your code. And this is an example or a manifestation of something called test-driven development, which is a really hot topic in the big software world out there. Test-driven development. Now, what I'd like to do is introduce Quest Code Tester as a mechanism for employing these 6 simple steps. Let me tell you a little bit about the Code Tester first. It's not yet production. It's brand new. We've been working on it for the last half year or so. It's currently in beta testing, and you can actually download and use the code right now, test it, and I'll show you the link for that very soon. We will be providing a special early release at Oracle Open World in October 2006, and it will be available as a totally free, full-use product for at least the next 6 months or so. And then we'll be producing a commercial release in 2007, but there will still be a freeware version. It'll probably have some restrictions, but at least for the time being, you can start revolutionizing the way you test your code, and hopefully you'll agree when you see this. So what does Code Tester do for you? First of all, it provides screens through which you describe the test you want to run. Rather than writing the test code, you tell it, here's the kind of test I need. It generates the test code for you, runs the tests, and displays the results graphically on the screen. So let's apply this now, these 6 simple steps, to a simple function that I like to use as my example, which is between string. So what's the required functionality? Between string is a variant of substring. Substring, you take a string, the starting location, the number of characters, and it returns that part of the string. But often I have a situation where I have the string, the starting location, and the ending location, like the first comma and the second comma. And I need the string in between those 2. Substring doesn't do that for me. So I wanted to do that kind of implementation. And I also want it to work as much as possible like substring. 0 should be treated as 1. I want to support negative starts and ends. I want to allow the user to specify whether or not to include the endpoint. Okay, let's actually follow this process through using Toad and Quest Code Tester. So first of all, I'm going to go to Toad, and I'm going to think about the general implementation that I want to pursue here. And I'm going to write just the header without the body. And I'm going to do that as follows. Don't worry, you're not going to watch me write code. That would take way too long and be full of too many bugs. Here's my first round implementation of between string. Pass in a string, start and end, inclusive. And it returns nothing. It just returns null. The reason I'm doing this is now I can make sure that my code actually does compile. And that's nice. I verified that my header is correct. And now I can build my test definition. Watch. I'm going to switch over to Quest Code Tester. Now what you see here is the dashboard. It's basically a console that gives me a high-level view of the state of my testing of my programs. And you can see I have 3 programs listed there in various colors. I'm not going to take the time to explain this right now. You can watch videos, tutorials that I've published off of the website. I'm going to click on the Add button to add a new test. I'll do it for between string. I press OK. And it takes me to what is called the test builder. And inside the test builder, I describe the tests, for example. And I'll just do a few of these. We don't have time for a whole lot of it. My normal usage says, well, let's put an A, B, C, D, E, F, G, go from 2 to 4, include my endpoints, and now I want to define my expected outcome. Now, generally speaking, when you're checking for the results of a program, you've got something that comes out of the program that was changed, and you have your control, what you expect. And you say, well, does the from program, change by program, equal my expected results? And that's exactly what you do here. Here's my change by program. It's my string, the return clause. I'm going to choose my operator, which is it equal to some other string? And the value of that string should be BCD from 2 to 4. I save it by moving it to my staging list of new test cases. I create another one. Let's do 0 start. ABCD. Go from 0 to 3. And I want 0 to be treated as if it were 1, so I'm going to say equal to a string. And the value should be, let's see, ABC. And I'll do just one more because we're kind of short on time. Let's do negative start and end. I've got ABCD. Let's put a few more in there. Give me some room. And I want to go from -2 to -4. And in this case, let's see that -2 to -4 should be DEF. Great. So what I did was simply brainstorm my test cases. And you can do lots more. You can generate multiple test cases for various boundary conditions. But this is good. Let's do a save, close, then run. Comes back to my dashboard, implements the definition, generates my test code, runs my test, and here's my results viewer. And my results viewer says, sorry, Stephen, your test didn't work. And I can drill down and see where it worked and didn't work. And in fact, what it's showing me is that all of my test cases failed. And you know what? I'm really happy. Because if I got a lot of green smiley faces for a program that does absolutely nothing, remember, we haven't implemented anything yet, I'd be really sad. There'd be something wrong. So I have a program that compiles, that runs. I have a test definition in place. Now I can start to build my program. And when you have a tool like this in place and you're following the test-driven development methodology, your test cases become your to-do list. For example, I want to test normal usage. So let's do the first round implementation. I'm going to hide my formula for substring, which is basically the number of characters is n minus star plus 1. I compile my code. I go back to code tester. I'll go to my dashboard. I'll run my program again. And I still get a red face. In fact, let's just show the most recent results. I still get a red face, but notice my normal usage is now green. It worked. Great. And now I'll go back to Toad again. I'll just do one more round trip and then explain the principles behind the process and the power of this approach. Let's say I work a whole lot more at it, and I come up with my ultimate implementation, which turns out to be really quite complex. Lots of code to handle all the different cases. I compile this code. I go to my code testing environment. Run my test again. Ah, what a nice feeling. All green. My program now works according to my test definition. So let's just draw out some lessons from what I just showed you. First of all, I haven't shown you behind the scenes what's going on, and you don't really have to see, but in fact there's not a lot to it. I generate a PL SQL package that does all the testing for you. But notice, the user, me, the developer, didn't have to write a single line of code. It was all done for me. And you'll have to take my word right now, but you can download and try it. It handles very complex test definitions, not just between string functions, but check to see if a table has the right results in it, for example. Check to see whether a ref cursor, a cursor variable, matches the contents of a collection. Check the contents of a collection. It's a very nice high-level way of defining your tests and working within a standardized environment. So my suggestion is that, first of all, you generally adapt the 6 levels, the 6 simple steps of testing that I suggested before. And one of the main approaches there is to define your tests before you write your code. But with a product like Quest Code Tester available, you can now define those tests and run them relatively quickly. You still got to do some work. It's not like it's all free. But you're mostly thinking about at the logical level what determines whether or not your code works. And one other point to make that's really important is that when you have a product like Code Tester available, the unit testing process, testing your individual programs, becomes a part of your development process. Today, the way we look at it is that we write our code, we work it out, we do a little bit of testing, but the bulk of the testing is kept for some later stage. That's a bad way to go. What's a lot better is you write code, you make a little bit of a change, you test. Write some more code, do another test. Make sure that nothing that was working before is now broken. So the iterative development of your code, tightly integrated to testing, completely transforms both the productivity and quality of the code you write. And you'll suddenly find that testing is not separate from development. They are mirror images, the two sides of the same coin. Okay, just about done. I thought I'd offer to you some resources to help you achieve best practices. There's a lot out there, and this is certainly just a subset. I'm really focusing on what we at Quest have to offer you. First of all, Quest Code Tester. It's currently in beta. It'll be going production as a special pre-release product in October of 2006 at Open World. But you can go to the unittest.inside.quest.com/index.jspa website, and you can look at the community. There's discussion forums. You can download the software. To make it easier for you, you can also go to unit-test.com, and you can find your way to this big long URL from there, unit-test.com. You can go to the PL/SQL programming portal, oracleplsqlprogramming.com, which I built and Quest maintains. Click on the Resources tab, and you can download lots of free resources for PL/SQL development. In particular, you can download all of my training seminars and all the demonstration scripts I was running today. And you can visit there and look around all you'd like. And by the way, any of the code that you download, any of the trainings that you download can be used for free without asking permission inside your own organization. Then there are the Quest pipelines. This is a non-commercial community for MySQL, Oracle, DB2, SQL Server specialists. And you can go to the Oracle pipeline and download, for example, a library of PL/SQL code called PL Vision, database analysis tools. There's an archive. There are discussion forums. Lots of great stuff. And finally, this is all free. All of this stuff is free. But finally, I do have to remind you that Toad and SQL Navigator both have a very powerful component called the Code Expert. This is I believe, a part of the Toad Professional Bundle, and it will allow you to automatically analyze and review your code, both to find SQL inefficiencies, but also to apply the best practices that I promote in my books and my talks automatically to your code and get a report showing you where your code violates or might be violating those best practices. These are fantastic capabilities built into Toad. Most of you have access to them, and you probably didn't even know it. Okay, so that's the end of my talk. I hope you found it interesting. I'd like to now turn it over to the operator, Lisa, to step in and facilitate any questions that you have that you can ask me over the phone. And also, feel free to offer your own ideas about how to write best practice code.
Thank you. The question and answer session will be conducted electronically. If you would like to ask a question, please do so by pressing star followed by the digit 1 on your touch-tone telephone. Keep in mind if you're on a speakerphone, and make sure that your mute function is turned off to allow your signal to reach our equipment. Again, if you would like to ask a question, please do so by pressing star 1. And we'll pause for just a moment.
So you might say to yourself, come on, Stephen, do you really mean that I shouldn't write so much SQL? And the answer is absolutely. In fact, I think as an application level developer, days, weeks should go by where you don't write any SQL. Selects, inserts, and updates are no longer a part of your everyday vocabulary for PL/SQL. How's that for a strange sounding best practice?
And we'll take our first question from Richard Ulmer with RBA LLC.
Hi, Richard. Are you there? Did you unmute? Can you remind them how to unmute their phones? Is it star 6?
If they use star 6, they'd have to use star 6 again, okay. Yes.
Richard, are you there?
And Mr. Ulmer?
Let's keep going.
Okay. And our next question will come from Chris Jawowski with WM Beaumont Hospital.
Hi, Chris.
Oh, one moment, just a minute.
I think we're experiencing some technical difficulties.
We have some technical difficulties. Just give me 1 second.
Sure, no problem. Okay, well hopefully we will be able to get your questions in just a moment. But in the meantime, I could just keep talking and talking.
Well, we do have a David Gale with Hypertherm.
Yes.
All right, Dave, I can hear you. Go, go, go.
A lot of my PL SQL uses the HTTP package to generate web pages.
Okay.
Does the code tester allow for testing that?
That is such a great idea. We don't currently have any built-in, we're not smart about HTTP packages, so no. And that's something we should be able to layer in pretty easily. And in fact, what I would love to do is follow up from this phone call. You've got my, did you see my email address there? You can just send a note to stephen.feuerstein@quest.com.
Okay.
And send me a note telling me that you're interested in this kind of testing. And what I'd like to do is follow up with you and talk about, more specifically the kind of tests you need to do.
All right.
Thanks.
And we have another question from Duke Coach with SIUC.
Yeah, I was just wondering, the talk was so good. Are the PowerPoints going to be available anywhere?
Well, the talk was recorded, so we will be posting it somewhere on Quest.com. I'm not exactly sure where, but I'd like to think that we can also send you a note with that information. I'll check with Tanika afterwards. And I can also take this material and put it on the Oracle programming site. In fact, I'll just start up a browser right now and just take you there so I can show you how that works. So yeah, we'll make sure it's available. And let me just tell you that even if you can't get this exact one quite yet, I'll show you where to go to get all the other stuff and one that's very similar to it. So you're now looking at the unit-test.com site. I believe you can all see that, yes. And if you go to the Oracle PL SQL Programming Portal, so you just have to remember the name of my book, the big fat one, Oracle PL SQL Programming. Click on Resources. You'll then see a list of all my different training materials. So for example, better than this 1-hour best practices class, you can click on Best Practice PL SQL, and you can get a day-long training material, 100 slides, that cover everything I talked about here in much more detail. You can download the PowerPoint. You can distribute them to everybody in your company. You can do your own internal trainings with my materials, no problem. And you can also download the demo zip file, which is on the main page. And this will have 400 or 500 scripts that I reference throughout my materials that demonstrate the techniques or provide reusable code. So visit this page. Again, you may not see this exact variant, but you'll have many other best practices to choose from. There's also another one called 21st Century PL SQL, which is my latest new features for PL SQL class.
That's great. Thank you.
You're welcome.
And we now have a question from Eugene Pipko with SPI.
Hi, Eugene.
Hi, Stephen. I wanted to find out about the table functions that you mentioned before.
Yes. Okay, so why don't I show you an example of a table function and show you a really interesting application of it, and that will give you some sense of what I'm talking about, because we don't have time for like the full exploration here. Let's look at what's called a streaming table function. What I'm going to do, I'm going to zip down through a bunch of this code and just show you the end result, and then I'll step back up through it a little bit. Here's an example of a streaming table function. Now what I need to do generally is perform a data transformation. This is a very common operation in the world of data warehouse. I have a bunch of data in my stock table, and I need to convert it through a complex transformation into rows in the ticker table. Let's not even worry about the details of the transformation. It's something that requires a lot of heavy-duty PL SQL crunching. Here's how I can do it all inside a single SQL statement. I take my select statement, and I pass it as an argument to a PL SQL function by calling the cursor expression, which converts my select statement into a cursor variable. I pass my cursor variable as an argument to my function. Here's my function. My function takes the data set as an argument coming in, and it passes back a nested table or collection coming out. I put the call to that function, which is the nested table, inside the table operator. The table operator says, take this nested table or V-array, this collection, convert it into a relational table format, and then query against it. So this is the basic idea. You write a function that returns a collection. You put it inside the table operator, and now it becomes eligible to be treated as a relational table inside your query. And I can do an insert, select from. I can even, in the context of these streaming functions, have more than one strung together or streaming together and do multiple transformations piggybacked on one another or daisy-chained to get to the ultimate point that I need in my code. So that's the basic idea, and we'll take a look quickly at the stock pivot function. It takes a data set coming in, which is a cursor variable. It returns a nested table, inside my function, I grab all the data in my data set, and I move it to my nested table row by row, and then I pass it back out. And that's the basic functionality, the basic approach needed to implement a table function. And a common way that you'll also see these used, notice here that I've taken this select statement, and I've put it inside an open for. This is a cursor variable. And what you can also then do, see if I can find a good example of this. You can create functions, like right here. This function returns a cursor variable. So here's an open cursor variable for, and it returns a pointer to this result set. This kind of cursor variable can be used by Java. So basically what you can do, especially with the table function, is bury arbitrarily complex transformations of data behind a function that returns a cursor variable. It's passed back to the Java interface, the Java front end, as a pointer to a data set. And the Java code can almost transparently, easily, fetch individual rows from the data set, display it, manipulate it, and close the cursor variable when they're done. And they never see the SQL, and they don't know that in fact they had to call a PL SQL function that did this amazing amount of transformational work. So that's a really quick intro. You can check the Oracle doc for more on table functions, and check my books as well. And in terms of Oracle documentation, let me just point out one more thing. I'm going to go back to my, where is it? Where did my, there it is. Right, go back to my Firefox session. Just so all of you know, you can access all of Oracle's documentation online by going to Tahiti, for whatever reason, probably the original name of the server, tahiti.oracle.com. You can type in the string name, the name of the thing you're searching for, like table function, and it will search across all the versions of the Oracle documentation, and then you can drill down into the version-specific stuff and find out what you need to know. It's a really wonderful utility that Oracle has made available to all of us. So hopefully that's enough to get you started.
Thank you.
Welcome. And let's do one more question, because I want to respect your time in terms of the rest of your lives. So this will complete an hour together.
All right, and we will take a question from Richard Ulmer with RBA LLC.
Excellent. Hi, Richard.
Can you hear me now?
I can hear you.
Okay. I'm a big believer in reuse code, but in that error handling process you had,
yeah,
do you feel it necessary to put everything in there? I always have a log package, but I leave a lot of it to the individual. In other words, basically all they have to do is have a procedure that writes to it rather than a procedure that does everything for them.
So you would have a procedure that
would write the log file, and they would just pass it parameters, but the procedure wouldn't do everything for them.
Well, you definitely. So I think I agree with you. Of course, I can only show so much detail in these.
Oh, I understand.
But really, so look at the example right here of the record recording continue. So clearly, the recording continue does let you pass things through. In fact, what I'm passing here is an override for the default message, which would be the SQL error message.
Right.
Because I want to be able to say which company ID had the problem.
Mm-hmm.
So I do think you need to have a way to pass the application context information.
Right.
But what you don't want to do is give them the ability to pass the call stack, the error message, the error trace. In other words, you ask the user to provide the context information that you can't get, and you gather everything else automatically and put it into your log.
All right. One of the things that I always want to gather is I want to know the program that ran, we call it the package,
exactly,
and where in that program you were going with it.
And do you know how to get that information? You probably do.
Yeah.
Okay. So for everybody else, there's a program called DBMS Utility Format Call Stack. DBMS Utility Format Call Stack. And you can call this anywhere inside your code, but an error handler is a great place to put it. And it will tell you the stack, A called B called C called D, and the line numbers upon which those entry points took place. There's another function called Format Error Stack that essentially returns the full untruncated error message. And Oracle recommends that you use this instead of SQL error message. Don't use the SQL error message function because it might truncate your message. And finally, just to fill out the discussion here, there's something called error backtrace, introduced in Oracle 10G. And this will point you back to the line number on which the error was originally raised. Really critical information that was lacking prior to 10G. So yeah, these are the kind of functions that you would call on the back end automatically for your user. But I agree, they should be able to pass the context-specific values.
Yeah. Okay. I appreciate it.
Thanks for the clarification.
Somewhere out there that that Q, I didn't write it right.
QNXO?
QNXO.
Yeah.
I did right. Thank you.